So, the first thing I want to talk with you about is the computer. And just a few basic comments. There's some misunderstandings about the 500 computer out there, and what you can do and what you can't, okay? And here's just some basic comments. The MG 500 computer is used on all current applications. I don't care who the customer is, or the dealer, or whatever. The 500 computer is current on all applications. In the 500 computer, the transducers are paired and matched to the board and cannot be changed in the field. I have to repeat that 6 or 8 times a day, or I have people call me and say, well, gee, I had an old computer over here and I took the transducer out and put it in there. So how do I fix it? Okay, and you don't. It's designed as a change-out unit. If the transducers are bad, you change out the entire computer. Currently, the duty file is programmed with the use of a laptop software and a programming cable. We've been with that program for about 3 or 4 years now. We had to change the design of the board, and there's several reasons for that. I'll kind of outline those as we walk through this. The older models use an EEPROM for the duty files. The serviceable components inside the 500 computer, okay, the serviceable components is a 10-amp fuse, and on the newest models, there is a daughter board in there that you can replace, okay? Those are the items that you can service in the computer. The MG 500 computer systems, let's go way back to where they started in 1999, okay? And we'll talk just a little bit about the series of it. And the design of this 500 computer started in 1998 at Greer in Santa Ana. The main forte of the 500 computer was incorporating the system with transducers into a single unit. This allowed the transducers to be paired and matched to the computer board and transducers, totally calibrated on the bench, okay? And what that means, when we assemble these computers at our factory, there is a whole line of computer programs it goes through, okay? It lines up on the pressure bench, it's connected up to the dead weight tester. Are you all familiar with dead weight testers? What they calibrate gauges with and things like that? It's perfect pressure. And that is calibrated zeros and spans on the transducers on that bench through a computer program. All that is stored on the computer board. Then the unit goes through the chamber, what we call the chamber, and that chamber resets all of the zeros at different temperatures. Okay, so the thing is temperature compensated, and they run it through this. It used to take about 11 hours to do all this testing, and I think they've improved on that now. So they put about 15 of these computers in the chamber all at once. Okay, when that computer comes out, the transducers are perfectly calibrated. There's calibration sheets you might have seen on computers coming out that tape to the bottom of it, and tells exactly what the tolerances were on that. On the 500 computer, you have a tolerance on the transducer 0 of plus or minus 75 psi, and that's not much. When you put that on the crane, 75 psi doesn't mean a lot. So the computer comes as a pre-calibrated standalone system other than the geometrical and calibration information of a particular crane load chart being loaded. This meant that the same computer unit can be used on many models of cranes, okay? So a Terex computer is an A450-832. They will put that computer on any of their RTs or truck cranes. That is a really valuable thing for the manufacturers. The other thing is, you know, you think about this, if you do it properly, if you change a transducer in the field, even on one of the old 400 systems, if you change a transducer in the field, you have to, if you're doing it properly, you have to be using the certified load to do that pressure calibration with. And I haven't seen too many people do that, okay? It usually, if they do it right, it's gonna take 5 to 10 hours of calibration work to recalibrate that, okay? If you can pay a little more for the computer and spend 45 minutes calibrating it, to me, that's kind of a wash, you know? And you're better off, the work's easier, it doesn't make an old man out of you clambering up and down the damn crane 40 times that day and stuff like that. Because I'll tell you what, when I first came with the company, they were just bringing this system in, and I'm telling you, these people were hot about not being able to change transducers anymore. And it took a long time to get that calmed down and to get them to realize, you know, that we're making their life easier with this. Okay, and there's extremes either way, but basically it makes life easier. When it comes time to do the finished calibration, all of the transducer pressure calibration is already present. So there's no need to do any additional calibration to the transducers. The geometrical and calibration data was loaded into the computer on a single duty file to complete the crane specific information as well as factory calibration data. So you see, we've already done the calibration for you. You don't have to do the calibration using this computer, on the OEM unit anyway. This meant that all that's required for calibrating the crane was zero and span calibration of the length and angle sensors and zeroing of the swing sensor. How many of you ever calibrated a 400 system for swing? Have you ever done that? Huh? How long did it take you?
Took it about half a day.
Uh-huh. Because on the old style computers, when you change the swing pot, you were required to sit in the seat and rotate the crane as slow as it would go, 2 complete revolutions, and then zero it and then spin it. Okay, with the 500 computer, you press one button and zero it, and all the information's already there. Okay, so it just made life easier. So let's continue here with the history of the computer. This meant that when a problem is encountered with the computer, the unit can be changed out in the field, and an hour or so later, the crane can be headed back into service. That's a fact. I've seen it over and over. There have been some generation changes in the hardware of the 500 series computers, and some part number changes on these units that will tell what generation the computer is from. Okay, so this is really important information for you guys as far as recognizing what you're working with. All these are 500 computers with one duty chip and the fast calibration, you know, where you just do zeros and spans. But what has happened in electronics, things turn over really fast, you know, and the products get better and things like that. They obsolete faster. It's kind of like you go into Best Buy and you buy a computer and you go back 6 months later and it's obsolete. They come up with something better, right?
Yeah.
It's not that bad with this type of computers, but this happens. So what we've done, we've developed a number of series for the computers by part number, which dictates which one is what, okay? You can see here, the first one, we have the A450-600 series. These numbers will change. A450-600 series, that's the first generation that was developed with a through-hole design in the board, and that meant that people are dropping the components in the board by hand. So component parts had to be hand set and then soldered, and utilized a pluggable 32-pin EEPROM socket for the duty file to reside in. So this went on for a number of years, and there was some components on that board, I don't remember which ones they were. One of them was the relays, became obsolete, and there was several other components that, you know, They come up with surface mounts. The surface mounts were more economical. They were wave soldered, so that the production was faster and more efficient. And we had an electronic transfer of the duty file. We do with a cable, and eliminated the need for the EEPROM, which, man, I said, goody goody. Because every time I did an OEM calibration with a 600 series computer, it meant that I had to burn duty chips over and over and over until I was just sick of fooling with them. I just hate them. Okay, so the A450 700 series was the next computers in line. This promoted the new design using surface mount components, solid state circuitry that's faster, more energy efficient, readily available. The computers also had a flash RAM technology for installing the duty file. This allowed the duty file to be installed utilizing a laptop, cable assembly, and a simple transfer utility to install that duty file. And later on, we'll do some duty file transfers here too, where you can see it hands-on. So that was the 700 series. Some of the manufacturers wanted to program the computers from outside without taking the lids off. And they came up with some different ideas as far as how to do this. And one of them was a computer that we designed for Elliott, because they was in a big hurry to get there. And it was a little plastic plug that went on there, you know, the push-on plug. I never was very fond of using those. Those were incorporated into the 700 series computers. So later, when all of the OEMs started getting on board with this pluggable memory transfer, it was found out right quick, you know, we were gonna have to do something with this plug. We have some samples of these up here. You can tell looking at Brian's cable here that this just beats the hell out of a little plastic push-on plug, okay? So the 800 series computers, they had some more internal changes of components, but we also went to this different type of plug to make this transfer system better. We could program from the outside, okay? So that was one of the mainstays of the 800 series computer that we're using today, was getting this external thing taken care of. Also, at that point, the relays inside the computer became solid state, a little better relay. So this doesn't particularly mean there's anything wrong with what they were built with before. It was just what was available. We thought we had a relay problem on the 600 series computers because we had one or two customers that kept burning them out. We set up a test on a test bench and had one of the software engineers generate a software that clicked that relay under load. We put 3 function kick-out solenoids on there, which is about twice rated load, and we cycled it 1,000,000 times. And the relay got so hot we had to cut the top off the relay and let it cool down, but it never faltered. You know, they're really good relays. So these new ones are supposed to be better though, so here we go. Any questions on that? That makes sense to you? You'll know what you're looking at, you know, by the series number. Look at the part number of the computer. We didn't talk about the label, did we? Every single computer that we produce has a label that looks like this. It says Greer Company on the label. It's gonna be right on the end plate of the computer. And you're gonna see this part number on here, this A450 XXX something part number is gonna be on every computer. And right away that can give you an idea of what you're looking at if you're replacing this. So, I just want to talk with you just a little bit about the duty file. And this duty file, we use a software, it's a custom software of our own that's called 5 charts. And in this 5 charts, we produce these duty files. It has a series of databases in it where we store all the data, and then we mix that with a program that utilizes the data that's on the file. So the duty file it's a unique combination of a database on the geometry, load chart, and calibration information for a specific model crane. When you get this duty file, which is emailable now too, this duty file will just say like 5 digits and a dot hex, or HEX, hex. And that's the file that it's only about 250 kilobytes, and that's the file that you download with the cable and put into the computer to change who it is, okay? It also contains a special program that manages how the computer system will monitor the crane functions by utilizing geometry calibration information to correctly display the inputs, outputs for the crane configuration. Okay? Identification of a typical duty file. This is really important. This can help you. The key to getting the correct duty file is the crane model and load chart information. Below just demonstrates how the duty file part number is broken down, okay? And you can see here, this is a typical label. On the electronic transfer computers, you'll have a small label like this that used to go on the duty chip, will now be put on the end plate of the computer, and we also put one on the inside on the wall of the computer, so that information will always be available. We can also view this information through the display. Okay, so there's several different ways you can get this duty file information. So, identification of a typical duty file, the crane model load chart information below demonstrates how the duty file part number is broken down. First of all, you have the D and E initials. A D is, for all intents and purposes, a duty chip, and E is an electronic transfer file, okay? And this kind of gives you an idea of how that's broken down. Okay, this is the type of file. The 510, and this may not be like this on every single instance, but mostly, this right here is an indicator of the display. It's a 510 or a 586. If it's an inside, it would be a 600 series. If it's an element, it'd be a 700 series. It's an identifier. The last 3 digits are a specific model number of crane. The last letter is an engineering designation, which tells us how new the duty file is. The type of display is called out as the model of the display used as below. The machine model is a numerical sequence that ties the machine model and load chart number and completes the part number. This all has to be done through the factory though, so it really isn't that relative to you guys out in the field. The revision level is revised every time there's an engineering change on the duty file. So you can see here at the bottom, so you got a prefix of 586 for an MG 586 display. A 600 would be for an inside display, just as examples. Anybody have questions over that or comments? Okay. So let's just talk a little bit about computer components, and hopefully this will help you understand why it's like it is as far as changing components in there. First of all, here, this is a 600 series computer, and we have this slot in here for the duty chip, the system chip. It's called IC16. All it is just a socket that has 32 holes in it for the pins of the EEPROM. We have internal transducers These can either be mounted out the end like this, or on some computers they come out the bottom. They're always marked rod and base side. We used to mark them with these colored bands. Now I think they actually scribe those into the end of the computer, because people kept losing the bands. Okay. There's a COM indicator in here. This is on the old 600 series computers. You have a COM light down here in the bottom of the computer that continually flashes to indicate two-way communication. You have an FKO fuse. This is just a standard 10 amp toolbox type fuse that can be replaced. It's for the FKO system. Moving on there, we have the computer components and the flash RAM computer after 2011. Okay? See, we don't have a CAN board in these because these are not element systems yet. They were not designed to use as elements yet, or insights. The CAN board is not used on the 586 and 510 computers. You have a COM indicator up here that flashes like always. There's also a row of indicators for power supplies. We have a flash RAM chip here, which is soldered to the board, non-removable. Your internal transducers, and of course the FKO fuse. So you can look at that and you can see there's really not a lot of difference between that and the old style board, other than the fact we use bladed terminals on the wires. And this has helped a lot with the production of these units, with people not leaving screws loose on wires and stuff like that. So that was a good move, moving to that type of fitting. So the computer components for the Insight and Element, it's basically the same, other than the fact we've added the CAN bus board, which is the little daughter board I was talking about. Everything else is the same on it. Any questions on those on the computers? Kind of gives you an idea of the progression of those. So here's something we haven't talked about, reeling drums yet. And I love to talk about these reeling drums, because I used to do a lot of work with the engineer that designed this thing. I used to laugh at him when he did his tests. He had one of these on a test stand that he built in the back that had a cycle counter on it. And he would read the cable around a bunch of rollers. You ever see Steve work on these Steve mills? And he was out there one day and he was cycling this reeling drum, full tilt, full load, everything. And he was back there piling dirt and sand and oil on it and everything, trying to make the cable not level on him. You know, he was testing out this guide system. I used to get a kick out of it. The jobs of this reeling drum are really quite simple. One of them, it was designed to keep the cable in a neat single layer, which drastically improves the accuracy of the length. The reeling drum houses the sensors, the length and the angle sensors, and the swivel for the 2-block wiring goes through there. And also transports analog signals to the computer from those sensors. So those are kind of the jobs of it. The previous reeling drum, previous to 1998, was what I've been referred to as the rectangular reeling drum, because it's made out of metal. It had a whole gear train of stuff in here that it went through, and an old copper collector ring. Stuff that is just way, way obsolete now, okay, we don't use anymore. It had a separate angle sensor built up for it. And this, we wanted to get these out of the field, so we designed a new round reeling drum with the same electrical plug that this reel had, and actually sets into the same footprint, okay? And that reeling drum is called an A240 690, And the bracket on that reeling drum will fit right into the footprint of this reel. It'll have the same connector on the outer end, it'll have the same connector on the back end, you know, so it's a replacement item, okay? So, maybe you can see from what I'm showing you here, why we replaced that. On angle sensors, we went from an oil-filled pendulum, into a new sensor that is controlled by magnets, okay? That pot used in there is a very, very expensive, very sensitive pot, and that's a pure copper pendulum that hangs off the shaft on it, and the movement is controlled by these 100-pound magnets you see here. And this is a drastic improvement from the old way of doing things. I used to work with the old oil-filled pendulums and hated working with them. These things, they're so easy to work with this. And you can take that pendulum, sometime if you work on one of these, just take that pendulum and raise it up and drop it and watch it free flow into those magnets, and you'll see it'll just come to a stop like that, into a very controlled movement. So this really works. Replacing the A240-160 with the current production A240, all of the manufacturers have their own part numbers for the new reeling drums on the new OEM models. That would be the 690 for the aftermarket. There's several different models of this reeling drum used by different OEMs. The current production reeling drum is comprised of plastic side plates and drum, everything incorporated into one central location under the cover. The main components are as follows: the side plates and inner drum assembly, the ring drum spring box assembly, which the spring is incorporated into a metal canister, a sensor plate containing the length and angle sensors. This sensor plate is built up and calibrated in our shop. We calibrate those with a machinist manual for 0 on the angle. And a collector ring for the ATB circuit. That collector ring resides right on the end of this coupling plate. See if I have a better picture of that. I guess not yet anyway, I'll get one here up a bit. But you have this little bracket right here, houses a collector ring. It's actually an 1/8" jack plug, a stereo jack plug with gold contacts is actually what it is. I'll never forget, they brought one of the first 585 units out to my shop after I moved to California and wanted to retrofit it to one of the ROBT 4792s. And they pulled that reeling drum up there and stuck it on the side of the boom. And I saw that collector ring, and I looked at Wade Little and I said, "You guys are nuts, that'll never last, you know." And the engineer that designed it, he told me, he said, "Think about it." He said, with the smaller pin, the smaller collector ring, you have less wear area. And it didn't make sense to me at the time, but I think that unit's probably still running around out there with the same collector in the reeling drum, you know. They're really a good part. It's a lousy service part because they're cheap and they don't break. So on the mounting of this reeling drum, we talked about this a little bit for the rope guide. We have a long rope guide, I think it's like 7.5 inches long. And that needs to be 48 inches from the center of the reeling drum to the first guide. And what that does, that causes this to go into a fleet angle as it winds itself across, and it will actually level wind every time. The reel requires only 5 wraps of pre-tension. This is something, as you're probably gonna hear this over and over as I go through these, you only need 5 wraps of pre-tension in order for the reeling drum to do its job of keeping tension on the 2-block cable, okay? Most of the old style reels, you know, the more wraps you put on it, the tighter the spring got, okay? This one doesn't work that way because the spring winds from the inside out. So what you get is a consistent 18 to 20 pound pull, even at full extension, okay? And smooth, very smooth. So here's some commonalities. All springs used on the 90-foot reeling drum and 110-foot reeling drum are of the same design because they all wind from the inside out, okay? The 90-foot model has 39 turns lock to lock, where the 110-foot has 55 turns. And what that is a count where you take and you turn the drum till it clicks, and then you can wind that drum 39 times and hit the end of the stop on it. And I've done that over and over, and it's accurate. But what you need to do is take and wind the drum 5 turns, and then throw enough cable off to reach the boom tip. You don't put 5 turns of pretension and then drag the cable out to the boom tip. You know, that's overloading it. And it's not like you're gonna break something by a couple of extra turns. It's just the idea that anything over 5 turns, start using a safety factor, okay? We've run as high as 50,000 cycles on an original spring and cable on our reeling drum. So on the boom length sensor, we use a term, pretty much a standard pot, 5K pot, but the potentiometer is protected from breakage by an internal clutch mechanism. There should be a sudden uncontrolled movement, like you break the cable or something. When it hits the end of the stroke on the pot, it clutches instead of breaking the pot. So although that's pretty generic, it's not. Because now, we used to do that with a little ball bearing detent clutch, but now we have a pot that actually has this clutch built into it. So it is a special pot, so you don't want to replace that with the other kind. The ATP A2 block, anti-2 block signal measured signal voltage, which is passed through a collector ring on the way out to the boom tip and will return to the computer. The signal passed through the reel by way of a collector ring assembly, which is what we just talked about, the collector ring. Here's our other reeling drum, this A250200 reeling drum. This is used exclusively by Broderson on their short boom machines. Anything in IC 80 and under uses this reeling drum to measure length width. It has a 35-foot span. It's a little different on the inside because it's belt driven, okay? There's a little board built into it, a little computer board built into it that contains the power signals for the angle potentiometer. You can see the angle potentiometer. This is identically the same angle potentiometer that we use on the other reel, but it's soldered into the board. So in order to change that, you need to order the whole assembly. There's a little plate assembly you can order. The length potentiometer is the same length potentiometer in just a little different setting. And I'll tell you what, when this first made this design, we made that as a result of the Marine Corps updating 186 machines in their fleet. They were LRT 110 Terexes. And we designed this as a throwaway reeling drum. Okay, it weighs 8 pounds. And you take 4 bolts out, you can stick another one on, and it's all preset to 0 and everything to make it changeable, okay? So that Broderson picked up on this for their smaller machines, because you put one of these 14-inch reeling drums on an IC80, you know, it looks ridiculous. So this reeling drum is specifically used on all the Broderson machines under the IC200. Everything above that goes with the large reeling drum. See, this doesn't require the long rope guides because it has like a level winder, kind of like a fishing reel, which just goes back and forth on a shoulder bolt, you know, and level winds that cable inside there. And then, of course, you got the cog belt. So, more about commonality, there's still commonality out there, you know? All of our reels use the same cable. They all use this PO 45106 type cable. For the small 35-foot reeling drums, you use 60 feet of cable. On the 90 feet, 130 feet of cable, and the 110 foot, 150 foot. Now, some of the manufacturers take exception to that for their particular reasons and want more or less. But here's an important fact for you guys. If you're testing one of these cables, you have to remember that both the inner and the outer cores are stainless steel, okay? Therefore, there's high impedance when you're continuity testing this. If you continuity test this cable end to end, you're liable to see 150 to 300 ohms of resistance. I've had people get ready to throw a cable away because it had that high impedance in there. And I found that out the hard way by asking one of the engineers, you know, because they were telling me that. But 150 to 300 ohms of resistance is not uncommon on the Greer ATV cables. Here's another thing about that cable. That cable has an extremely tough outer coating. And with that stainless steel inner, if you're shredding that outer core and then twisting it, it will just cut your fingers all to pieces. I did that with, I always did those with my fingers, right? And I did that with one of our cables, and I had little cuts all up and down my fingers from that. So I got to working with one of our field guys, and he showed me this little trick of stripping that insulation back and then pushing that coax down and pulling the center through the hole it made. And you just have two made up leads right there. And you don't cut yourself up. A nice little field tip. We have our own recommended methods of strain relieving this cable. One of them is this is a system that we made in RO way back when we first started in 1984, putting the Kruger switches on them. And they were having problems with those little clamps eating through that soft shell, shorting out. So we come up with this method of wrapping the cable around a thimble and using a 3/8 glue type heavy wall shrink tube and shrinking it down on there, including the metal loop up here. We push that right up on there and shrink it down and tie wrap it in a couple of places, and it made an excellent strain relief. The other method is this little stainless steel clamp that's been out there many years. And with this new tougher outer on this cable, these work successfully without eating through the cable and causing shorts. So this is now an acceptable method of strain relief. The other method is one that Terex uses, where they have a welded metal post on the boom tip, and they take and put several wraps of cable around the post and use what we call a tiller clamp, which is just a flat clamp with a couple of grooves in it, tightening that down on it, maybe throwing a couple of tie wraps around these loops on the boom tip so they don't get loose, and forming that strain relief. And there's the better shot of the collector ring, I promise. All Greers use the same collector ring in the ATV. Now, you know what, I may be behind on this a little bit because I know that they have come up with a new type collector ring for the little plastic reels. It's a different type of collector ring, and they've upgraded. Have you seen it? They've upgraded it on the drawings and everything. And it's a lot better collector ring. It's easy to work with. But this jack plug design has been with us ever since I've been with the company for the last 15 or 20 years here. And we have specific part numbers for those collector rings. Okay, this S24602 is exactly what you see in the picture here with this bracket, with the pin and then this other little bracket that has the collector ring built into it. You can buy that as an assembly and replace that. And, man, I still think that's a lousy service part. I don't think we sell many of those. And that same design was incorporated into the small plastic reel in the beginning too. This just shows the mounting of that, where it's mounted on the sensor plate assembly. Here's a picture of the boom length potentiometer and how it's mounted to the sensor plate. You can see this metal boss here is what actually slides over the shaft on the reeling drum, and then that's rotated to the zero direction with your movement zero, and you tighten down a set screw in there, and then calibrate your sensors. So this drive gear on here, this sets up like a 4-to-1 ratio on that sensor. That's why they've got all the gears on it. Now, I talked just a moment ago about the clutch, and I mentioned to you that at one point we had a ball detent clutch, and this shows you both of those designs right here. You can see on this gear here that they counterboard that surface of the gear, and it has a spring in there, and then a ball on top of the spring, and this aluminum clutch plate has 4 indentions drilled into it, whereas you rotate the gear around against the stop, the ball detent drops into the hole. Later on, one of the manufacturers developed a new kind of pot, and this pot has a clutch built into the bottom of the actual pot. So you can take that shaft and rotate it against the stop and keep rotating, and you'll feel the clutch drag, okay? So it's a good device. We've had really good luck with these. The only time we've gone back and used the detent clutches is when they ran out of these. And that hasn't happened lately. That was 5 or 6 years ago. We had to put out several hundred of these. But, I mean, the only way you can tell the difference is the new design drags, the old design clicks when you turn it past the stopping point, okay?
And I just want to spring.
Now, your boom angle potentiometer, this is a different animal here. There's some rules that go with this. One of them is I always try to talk people into buying the plate assembly rather than the pot, because if you don't set the pot up right, if you don't time it right, you will actually run out of tracked voltage measurement on the pot. The pot has 120 degrees of movement in it, of tracked movement. So there's a little notch on the end of the shaft you have to line up with the bracket on the pendulum, and then it has to be set at a certain place, or when you raise the boom up and down, you will run out of tracked movement, and your display will just drop into dashed lines. You know, you'll get no voltage output from the pot. But you have your angle potentiometer there, your copper pendulum that swings in front of these 100-pound magnets, okay? For that controlled movement, very nice controlled movement. So here's a little close-up of the pot, and this pot. Here you can see how these wires are turned in here. They consistently set that pot up in there and tighten it down in assembly and calibrate the zero on it. They do that right on the test bench. If you buy the plate assembly, all you gotta do is snap it on there, level it, tighten the set screw, and you're in like Flint and you're off and running. So, because that shaft has a little arrow kind of thing cut into the end of the shaft, that if that's not aligned with this crack in the hanging bracket on the pendulum, then you will definitely run out of tracked voltage band. You will run out of the voltage signal at the wrong place. So that has to be timed, and then it has to be rotated properly to get the crane voltage at 0 degrees. And then it also has to have breathing room between this plastic bracket and the platen of that sensor, or it'll hang up. It's an intricate little process to do. So we always try to get people just to buy the sensor assembly and just do the calibration and tighten it up, you know. The thing's gonna last forever anyway unless they drop it. All right, let's talk just a few minutes about 2-block switches. This is our other product that there's several of out there. And this is what we call the heavy duty switch. And this is the original switch that Gerald Greer designed. And I mean, when he says heavy duty switch, he meant heavy duty, because this is one heavy duty little mama. If you look inside there, this switch has this big old heavy duty iron trigger in there that sits on a roller bearing. Okay, so this actually sits on a ball bearing in there. This heavy back end of this switch holds the switch in an open position until you hang a weight on this trigger. See that hole in the trigger? You hang a weighted chain on there, and that will actually pull that trigger down, and it pulls up to within a certain gap of this proximity switch. This is a little proximity switch that when it gets up to a certain place, the switch makes. Okay, this is manipulated with a rubber stock. So this is a switch that's wired up for boom trucks, because Terex didn't want to go with any of the new design switches. They wanted the heavy duty switch on their boom trucks. Okay, so this is wired for them. This is a little close-up of the switch. Also a repair kit number. If you get one of these you want to repair, you can order a repair kit that will have the bearing assembly, the bolt, a new switch, a new mounting for the switch, the new rubber, we'll call them rubber baby buggy bumpers. Yeah, I believe I need that. You know, all these different parts, and you know what those cost? I have no idea what they cost. They're not very expensive, it's like $60 or something. And you can overhaul that switch. So basically what we have here coming out of the 2-block system on any 500 computer is a voltage, a measured voltage signal, okay? And if you look at your card, can I borrow your card? Don't slack me. If you look at the bottom of the card on the back side, on there it gives you a voltage measurement sequence to test out your 2-block circuit. Okay? Because on our 2-block system, the computer sends out a measured voltage signal to the switch at the boom tip and brings back a measured signal to the computer. Okay? And if the computer doesn't see this particular voltage pattern, then it considers it to be an alarm. Okay? And so it's what I prefer to call it is a voltage continuity system, whereas the old 400 computers were a ground signal. Okay? We went from ground to a measured voltage signal. So nowadays we have redesigned that switch, and I'll tell you what, we did a lot of table pounding over this, because I had trouble with switches early on when I was a dealer out in California. The OEM and aftermarket ATB switch, straight mount, has a mounting bracket that looks like this that actually bolts to the boom tip, and you'll bolt one of these to the jib also, so you can float that switch back and forth between the boom tip and the jib. Okay? Elliott is using this across the board on their cranes right now, as we speak. They use this switch. This is the switch that Terex didn't want to use for reasons of their own. We designed this with a machined aluminum body and a plunger that sets up here on this shaft and actually just actuates a little micro switch. Okay? When I had a problem with one of these in the field, I went and bought the micro switch at Radio Shack. Uh-oh. This means that PAT guy's gonna show up again. He didn't get the secrets. Okay, so quickly then, what we have here, in this switch, they put a new type of spring in there. Any of you ever hear of a waffle spring? It's actually it's like a series of thin washers that spot welded together, and they actually go back and forth like this, and it forms a flat spring. It's kind of, I wish I had a picture of it, I'll show it. It's really cute, and it works really well, okay? So what we did with this switch, we made all of these parts replaceable. So you can replace the cable assembly in here, keep using your nice formed aluminum body. One of the upgrades we did to these switches from early on, we used to have problems with cables that we used bleeding moisture through and getting moisture into the switch, okay? So we went to a potted cable, potted connector. We also put a drainage hole through one of the bolts in here to keep that drained of any moisture. You know, we did some serious upgrades on that. We followed through with that into the one that we call the super switch, which swivels. I thought I had a picture of that in there. Okay, so this is the new design. We sell these on aftermarket kits. We sell them as aftermarket replacements. That switch by hole pattern will actually replace a brand X switch, the same bolt pattern. Okay. I really can't think of much more to say about it right now. We'll have some more on it as we go through. The displays, let's just run through the displays quickly here. This is a picture here of years ago, back in the early 90s, the MG 400 series displays. You can see this is a 424. That was an aftermarket setup. There was an OEM display that was called a 414, and they were same old, except for that number, okay? This display is totally obsolete now, as well as the computer with it. And they're being replaced by the 500 series computers and the 510 displays. This was a graphical display. You know, Terex wanted buttons, pictorial buttons. LinkBelt wanted pictorial graphics display. So they come up with this 434. Here's the horizontal model of that and the vertical. Both of those are out there on LinkBelt cranes. Or no, wait a minute, that's the 500, the RCI 500. Excuse me, yeah. This kind of looks like the one that we built for LinkBelt, you know, with the glass over in the corner and all that. So, okay, so that's kind of the introduction of graphical displays, easy setup and calibration. That's what we wanted to talk about there, the introduction of graphical interface. Okay, going away from the 414s, we went into this graphical interface where you punched a button and something happens and shows up on the screen. LinkBelt chose to do it with these graphics internally here. Terex chose to do it with buttons that light up. Okay? The RCI 510 and the 586 became Terex's flagship displays. The displays featured graphical screens, very easy setup. Actually, with the exception of the 586, because everything's done in words. But it was such a step ahead of the 585 it replaced.